Everybody. Today we will start with section 7.2, the direction of reversible reactions. First of all, let's just take a look at this reaction. We can notice that this reaction is a reversible reaction as it's composed of two reversible arrows. But we just noticed something that the length of this arrow is longer than this smaller one here, or the shorter one. So what's the reason behind this, or what does this mean? Generally, it tells us that the rate of the forward reaction is greater than the rate of the reverse reaction. And that's why it's represented by the longer arrow. What does this mean? It means that the reaction is favored to produce more products than reactants. And since you have more products than reactants, then the ratio of the products to the reactants will be greater than 1, since the products are greater than the reactants. All right, now let's jump to the next case. The next case represents that we have a longer arrow that shifts towards the reactants. And that means that the reactants here are produced in a higher rate than the products. So in other words, the ratio of the products to the reactants, since we have more reactants, then the ratio will be lower. Okay. By the way, we're going to cover this ratio, which is represented in terms of K, or K equilibrium, or equilibrium constant K. We have K that represents the ratio between the products to the reactants. And since we have more reactants than products, then the overall magnitude will decrease. And that's why the value of K will be less than 1. In other words, this reaction is favored to form more reactants, and the reverse, in other words, is more favored. And now, finally, let's jump to the third case at which we have two arrows, they're reversible, and they have equal lengths. And this means that the rate of a forward reaction is the same as the rate of reverse reaction. So the speed of changing the reactants to the products will be the same as the rate of changing the products to the reactants. By the way, we call the case at which the rate of forward and reverse reactions, when they're equal, we call it an equilibrium. Okay, so the equilibrium indicates that the rate of both forward and backward reactions are equal. So it's represented in this way. I hope you got the ideas today. If you have any questions, you can ask me in the comments below. Have a nice day.